The way we have made technology is fundamentally problematic. And you'll notice all three of these relate, but there are distinctions. It's fundamentally problematic independent of how we use it. There's this idea that tech is not good or bad, it's values neutral, and it's whether we use it in service of which values. We can use a hammer to build a house or to, hit somebody as a weapon. This is not true. Technology has certain fundamental and inexorable effects in its existence that we actually have to factor. And so inherent to increasing power is, the nature of how embedded within a rivalrous game theoretic dynamic, it will lead to the utilization of that power for rivalrous purposes. You can't not use it for rivalrous purposes inside of those dynamics. So that's how it relates to the first topic. That's the multipolar trap. And where if anyone uses it for the fucked up purpose, everybody has to, or they lose by default. And we can't assume that other people aren't going to. So we want first mover advantage on using it for the fucked up purpose. Right. But then also, so technology embedded within a rivalrous context will get used for rivalrous purposes. Technology defined in narrow ways ends up causing these problems with the other one. But as we even look at things like the biosphere is made up mostly of 6 atoms that almost all organic life is made out of, and trace amounts of the rest of the periodic table. But most of the nickel and the chromium and the iron and the uranium and the lead and the mercury is bound in rocks way deep underground, far away from the biosphere. And it actually took geological processes and hydrological and then early biological process billions of years to get it that way, right? To get the distribution of stuff where we mostly had the organic elements all circling within a very narrow biosphere. So the tree is made of the same stuff that the frog and the gazelle and the lion and the virus are all made out of, right? And as a result of that, when the tree dies or the lion dies, the microbes can eat it, and then the tree can eat it, and so the actual elements of which everything is made are the same elements with similar distribution, and so we can have closed cycle process on it. Now, as soon as we start mining and we start pulling up things that are fundamentally toxic to biology, right? The lead, the mercury, the arsenic, the whatever are all toxic things. We start pulling it up in huge amounts, and then we start doing the smelting and refining where we have both the active product is toxic and the tailings are also toxic, and now we're leaving them up here in the biosphere. We're undoing what took billions of years to make, which was the right elemental constituents for a healthy biosphere. Well, that's a fundamental problem, right? So either we have to make our built world mostly out of the same elements that nature makes stuff out of, or if we're going to use other elements, we have to figure out how to have closed loop atomic cycling on them so we don't have to keep taking them out of nature, and where they don't become pollution, they become like atomically accounted for cycled processes, and where those processes that we create, we can ensure aren't going to break down into the future. So inherent to the nature of something like mining is an inherent toxicity independent of how we think we're going to use the stuff, right? We can give a bunch of other examples of like inherent to the nature of an internal combustion engine is it can't not pollute and it can't not depend on resource extraction. It's just built into the nature of the tech. It doesn't have anything to do with what we try to use it for. And this has something to do with making things that are totally different than the evolutionary precedent of the biosphere and of a different kind. We make complicated systems, nature's complex systems. Also, the interface between the complicated and complex is that the complex is anti-fragile. You burn a forest, it regrows. The complicated stuff that we build is fragile. You burn a house down, it doesn't regrow. And so as we are killing more and more of the anti-fragility of nature and converting it into the complicatedness of the human-built world, we're decreasing the anti-fragility of the biosphere and making an increasingly fragile human-built sphere. That's also a collapse scenario. So This doesn't mean we aren't going to have tech, but it means we have to think about it fundamentally differently. We have to think about it in a much more considerate, holistic way, where we're thinking about what is intrinsically the entire effect across the entire supply chain of effect of the development of this tech, not just the really obvious effect of how I utilize it. And so again, this requires a different level of both motive and sense-making capacity to be able to develop it rightly. So now when we look at all of the catastrophic possible risks, whether we're looking at any of the environmental dynamics or social collapse or warfare or unintended consequence of exponential tech, we can see these generator functions underneath and driving all of those scenarios. So then we can say, if we could solve for these generator functions categorically, which means methods for humans interacting that is anti-rivalrous, that is building tech in relationship with the natural world in a metastable way, and that is defining problems in a comprehensive enough way that the solutions don't create worse problems, then we would actually have a human organizational system, a choice-making system that was not driving its own collapse.